This is strategic math. So in our sixth lecture, we're going to talk about polynomials. So this lecture is actually quite different. We're actually not going to present a theme, but a jumble of things that I would like to talk about. So actually this is just a crash course on polynomials. So I would like you to first watch two videos that I have already concluded that involves factorization, which is currently in the number theory playlist. So there will be two videos in that playlist, and I would like you to watch it because those techniques that I have talked about in the videos will be especially important in our video. Not actually that important because in today's crash course we're going to talk about quadratic equations. We're going to focus our full power on how to solve problems that involve quadratic equations. So let's begin. Question 1. So in this question, it gives you 3 quadratic equations, and it says that alpha is the common root of these 3 equations, and it asks to solve for the value of this. So how will we solve this problem? Well, if we do some observation, we can find that this is actually a rotational polynomial. So we've already talked about how to factorize rotational polynomials in the video. So in this video, I'm going to talk about how we will solve these kinds of polynomials. So a common way for us to solve these kinds of rotational polynomials is to add these 3 equations together. When adding these 3 equations together, we can find that a plus b plus c times alpha squared plus alpha plus 1 will be equal to 0. Well then, we'll clearly see that this one must be greater than 0, because we can further simplify it into alpha plus 1 over 2 squared plus 3 over 4 is greater than 0, because this part must be positive. This means that a plus b plus c will be equal to 0. So let's simplify the thing that they want to solve. So we can simplify it into this form: a cubed plus b cubed plus c cubed all over abc. So if we use some of the things that we've learned in the factorization videos, you can clearly see that we can change this into something like this. So by changing this into this, we can further simplify it to this form. Now we can clearly see that the answer for this question is 3. And this is how we solve our first question. So let's now look at our second question. It asks to solve for x in this equation. So this question doesn't seem to be something that we'll talk about, because it involves not only one root but 2 roots, and it has x in its exponents. So how will we solve this problem? Well, to solve this problem, we have to talk about something called the Vieta formula. Oh, by the way, you can pause the videos at any time if you want to solve this problem by yourself. Okay, back. So the Vieta's formula says that if there's a quadratic equation that looks like this, the sum of the 2 roots will be a over minus b, and the product of the 2 roots will be c over a. So let's now look at how we will use Vieta's formula to solve this problem. Well, you can observe that when 2 plus the square root of 3 times 2 minus the square root of 3, the product of these two will be equal to 1. This means that if we let this equal to a and this be equal to b, then a times b equals to 1. And we can also get that a plus b will be equal to 4. So a will be equal to this, and b will be equal to this. So let's make this clear. Okay, so after these two, by the Vieta's formula, we can now construct a quadratic equation using the thing that we found. So the quadratic equation will look something like this: t squared minus 4t plus 1 equals to 0. And if we solve for t, t will be equal to 2 plus minus the square root of 3. This means that the square root of 2 plus the square root of 3 raised to x will be equal to 2 plus minus the square root of 3. This means that x will be either equal to 2 or negative 2. So this is how we can solve this problem using Vieta's formula. So the goal of this problem is for you to learn how we can use Vieta's formula to construct an equation that we can solve and then get the answer that we want. So there are actually many other kinds of problems that can use these techniques. And maybe we'll talk about more of them later of this video. Our third question. So our third question will also involve Vieta's formula. It says that P is between 1 and 20, Q is between 1 and 10, and it says that in this equation 4 times x squared minus px plus q equals to 0, it has two roots alpha and beta, and these are both odd numbers. So it asks for you to solve alpha and beta. So we'll use the Vieta's formula. We can clearly see that alpha plus beta will be equal to 4 over p. Alpha times beta will be equal to 4 over q. Because an alpha and beta are odd numbers, we can do something like this. We can see that 4 over p will be between 5 and 1 over 4. While q over 4 will be between 5 over 2 and 1 over 4. So alpha and beta are odd numbers. This means that this will be an even one, and this will be an odd number. Because this is an odd number, this means that this number will be equal to 1, and that means we solve for q, which is equal to 4. So if we want to solve for p, we'll have to close the range around p because there are still many possibilities for 4 over p. So if we want to find another range for p, we'll use the determinant of this quadratic equation. So this is actually a very important technique. If you want to get the range of the root or the range of something, you will need to use the determinant. So the determinant of this equation will be equal to p squared minus 16 times q. This must be greater or equal to 0 because it has two roots. This means that what we get is that p must be greater or equal to 8. That means 4 over p must be greater or equal to 2. Because 4 over p must be greater or equal to 2, and we get that p over 4 must be lesser or equal to 5, this means that p over 4 must be equal to 2 or 4. It means that either p is 8 or 16. So let us put these two into the equation, and we'll also put q equals to 4 into the equation, and you can find that p equals to 8 is the only solution that we can get two roots. Because if we get 16 into the equation, we'll get irrational roots, which is not an odd number. So when p equals to 8 and q equals to 4, you can find that the two roots are both equal to 1. And this is how we solve our third question using Vieta's formula.